Hi, this is Dr. JMR Chemistry. Today I would like to explain some important questions which are present in a mole concept. Welcome to JMR Chemistry channel. So these questions it will come in various competitive type of examinations. First question, the mass of 3.011 into 10 to the power of 23 sodium carbonate molecules is dash. How you have to do? Here, generally, I'll explain two methods. 3.011 into 10 to the power of 23, that is sodium carbonate molecules is equals to mass means always you have to take in grams. Then here generally according to the our standard statement, any substance that is 6.022 into 10 to the power of 23 sodium carbonate molecules, or you take any molecule, this figure is constant, this figure is known as Avogadro's number, is equals to the respective gram molecular weight. Then what is the gram molecular weight of sodium carbonate? That is 2 into sodium, that is 23, plus here one carbon atom is there, 1 into 12 plus 3 into 16 is nothing but 106 grams. So 1 mole is nothing but here 106 grams of sodium carbonate. Then here by using crisscross method, then 3.011 into 10 to the power of 23 into 106 divided by 6.022 into 10 to the power of 23. So here you have to take molecules one side, then grams you have to do like that. Then finally you will get the mass. So these many molecules mass is equals to this value. This is by doing 1 then here 2 then here 2 ones are 253. So answer is 53 grams. So B is the right answer. Or in another way, the given number of molecules, that is 3.011 into 10 to the power of 23 divided by Avogadro number and the respective substance. So given molecules 3.011 into 10 to the power of 23 divided by number of molecules 6.022 into 10 to the power of 23 into Avogadro number. So like that you will get a 53 grams. Next, the number of oxide ions present in 10 moles 10 moles 10 moles of aluminium oxide Al2O3 is equals to how many oxide ions? That is nothing but O minus 2 ions. Generally, here if you will take aluminium oxide Al2O3, it contains Al plus 3, then oxide is O minus 2. Here how many aluminiums are there? 2. Then here how many oxygen atoms are there? 3. Indirectly, 1 mole of Al2O3 is equal to, atoms or ions means only one figure, that is Avogadro number 6.022 into 10 to the power of 23. Then you have to multiply with 3. Why? Because here 3 oxygen atoms are there, so that is why you have to multiply with 3. Then put X, 1 mole, 3 into Avogadro number, then 10 moles, how much? Crisscross. Then how will you get? That is 10 into 3 into N naught. It is nothing but indirectly, not directly, 30 into N naught. This is your answer. Answer is D. Okay. Like these questions are very, very important in various competitive type of examinations. Next question. The volume is asking volume at STP do, that is 1.505 into 10 to the power of 23 laughing gas molecules occupies this much molecules, that is nothing but N2O molecules is equals to dash ml. Then here already I explained 6.022 into 10 to the power of 23 molecules of N2O generally occupies 22,400 ml. By here what happened? If it is an ml, you take 22,400 ml. If it is liter, if you want to express in liters, then you have to take here 22.4 liters. Then here result will come in liters. The next, do crisscross. Then automatically the given number of molecules, that is 1.505 into 10 to the power of 23 into 22,004, if you will take like that, then here you take 6.022 into 10 to the power of 23. Then here cancel with each other. Then here 4 times 1 ones are, then here 1 4 times, then 4, that is 5.6. Answer is 5.6 liters. This is in liters, so that is why you will calculate in liters. You take liters matching. Then here this is called molecules. Then you have to take in molecules only. That's the relation. So like that, indirectly, given number of molecules divided by Avogadro number into 22.4 liters. Next question. The mass of 5.6 liters of neon gas. So neon gas occupies at standard temperature pressure dash grams. Indirectly 22.4 liters of neon gas is equals to 20, generally 20 grams of neon. This is a standard statement. To take any gas, this is common. 22.4 liters. This is nothing but the respective gram molecular weight. This is equals to X. Then crisscross. What do you get? 5.6 into 20 divided by 22.4. Then here 5 ones are 55.1. Then here you will get 4 times 1s are then 5. Then finally you will get 5 grams is nothing but 5.6 liters. Mass is 5 grams. Our next question. The number of gram atoms of oxygen present in 6.67.2 liters of nitrogen dioxide STP is equals to dash gram atoms. Then here, generally according to our standard statement, but here is asking only oxygen atom, gram atoms of oxygen. Generally, 22.4 liters of NO2 occupies 2 gram atoms of oxygen. This much contains how much? Then crisscross, you will get a 67.2 liters into 2. Why here 2? That's very important because he's asking only oxygen atoms. So that is why 2 gram atoms. Gram atoms are nothing but moles. So 6.2 into 2 divided by 22.4. That is 1 11.2. That is 6 times. Then you will get a 6 gram atoms. 6 gram atoms of oxygen is nothing but 67.2 liters of nitrogen dioxide contains 6 gram atoms of oxygen. Answer is C. Then here, calculate the mass. Is asking mass of sulphur in a aluminium sulphate. Aluminium sulphate formula is Al2SO4 taken thrice. First of all, we'll calculate the molecular weight of aluminium sulphate. The 2 into aluminium, that is 27, plus 3 into sulfur means 32, plus y, you have to multiply with this one. 4 3s are 12, 12 into oxygen 16, then 342 grams of aluminum sulfate. So here in this is asking only sulfur. Sulfur means what? Here 3 into 32 is nothing but sulfur. How many grams? 3 into 32 is nothing but here 96 grams. That's how C is the right answer. Next, like that, you will get 96 grams. Answer is C. Then we'll go for next slide. That is the mass of, is asking mass of methane, that is 5,600 ml of methane gas occupies how many grams? So here the given information is in ml. Then you have to take in ml. 22,400 ml. Generally, you take any gas here, methane occupies the respective molecular weight. 12 plus 4. 12 is carbon and 4 oxygen is nothing but 16 grams. So this much contains how much? Generally by using crisscross method, then 5,600, that is given ml volume, divided by 22,400 ml into 16 grams. Then here you will get a 1 4 then here you will get a 4 grams. Answer is what? D is the right answer. Next question. The number of nitrogen atoms. Laughing gas formula is And to here 22.4 liters. This is liters. Is asking dash number of what? Nitrogen atoms. Is asking dash number of nitrogen atoms. Is nothing but 2 into 6.022 into 10 to the power of 23. Why? Any gas occupies the respective what you call the Avogadro number. But here asking what nitrogen means you have to multiply with 2. So our answer is nothing but D is nothing but 2 into 6.022 is nothing but 12.044 into 10 to the power of 23. Our next question. Then here the number of grams of oxygen present in 342. So 342 grams of aluminium sulphate that is taken thrice contains how many grams of oxygen? Generally, here the molecular weight of aluminum hydroxide just now we saw that is 2 into that is aluminium water sulphate 2 into 27 plus 3 into 32 plus 4 3s are 12 into 16 is nothing but 342 grams of aluminum sulphate. Generally, so he's asking only what is the mass of oxygen, that is 12 into 16 grams of oxygen. So 12 into 16 is nothing but 192 grams. Our answer is A. A is the right answer. Then next question. The mass of oxygen, it is nothing but he is asking 8 moles of aspirin, that is C9H8O4 is equals to what is the mass of, that is grams of oxygen, is asking only oxygen. Generally 1 mole of C9H8O4 is equals to how many grams of oxygen? Generally grams means oxygen, that is 16, but how many oxygen atoms are there? 4. Then 4 into 16 grams of oxygen, this much contains how much? Then how you have to do? 8 into 4 into 16. 8 into 4 into 16 divided by 1. Then what do you get? 512 grams of oxygen. So answer is D is the right answer. Then next question. So here 10 questions are enough. So we'll go for next what do you call in detail explanation in next video. So thank you very much. JMR Chemistry. Please like, share and subscribe. This is Dr. JMR Chemistry. Thank you.